If you're lost and you're stuck, please don't stare blankly into your questions. Please actually raise up your hand and ask something, boys and girls. Maybe it looks loud. So let's do this one. Do this one, right? Yeah. Who about this? The girl that is that is oh, we are going to explain how a transformer works. I told you before, right? 4 marks for sure is going to be explaining how the whole transformer works.
Take a DC current.
Yeah, write that down. You need to. Yeah, AC current flows through the primary coil.
Yeah.
Yeah, refer to the loop fusion. Just read about that. So. We have the fishy self little.
Check on something on the target.
But
Wait, not again.
you get more you look really now. Usually,
Not this is not money. The army.
one,
Two
next one.
that explaining about any part of an AP.
You get 1 mark saying the magnetic flux. You get another mark saying it's set up. When nothing was supposed. I played right now. Oh. Okay, everyone. For those who are stuck and didn't know what to write, like I've said before in class, guys, as soon as you see that there's 4 marks in this exam question, right, and you have already identified that obviously this is a transformer question, you need to know that you're actually literally supposed to write everything you know about how a transformer works. Okay, the question will say something like the output voltage of the transformer is greater than the input voltage. Explain how a transformer produces this output voltage. There's one more extra twist here, guys. You're supposed to mention that there are more number of turns in the secondary coil than the primary coil, which will give it an extra voltage. But essentially, everything is exactly the same thing. You're going to say that alternating current is connected to the primary coil, which generates an alternating magnetic field, which passes through the soft iron core. This changing magnetic field cuts through the secondary coil. I keep saying this over and over again. The key word is it must cut through the secondary coil. It must cut through the secondary coil because that's how electromagnetic induction occurs, right? Cuts through the secondary coil, generating an EMF and an EMF and inducing current. The voltage is higher at the output because there is more number of turns. Something along these lines. It doesn't have to be word by word. Literally, you can use your own words, but it must have these few key points, guys. Right, and then you get your 4 marks. Bam.
Maybe this would be better.
Okay. This is good. Seriously, you must try
Works.
watch it again. This is good. Seriously, try it. You know something else. It's pineapple pie. Good. 你最后一个机会。在这里。一个这两种pineapple pie。我女朋友的，她是弄的很好吃。对吧？好的。OK， done。Yet again, guys, I keep emphasizing over and over again. This is not an English exam. You don't have to write it word by word, but you must have the key points, guys. Please make sure you know the few key points here. Definitely AC power supply connected to the primary coil. Definitely changing magnetic flux generated in the soft iron core. Definitely this magnetic field cuts through the secondary coil, which generates EMF first, then current, guys. I keep saying EMF first, then only there is current, guys. I said it over and over again. Okay, everyone. Oh, I'll be faster. Okay, then after that, there are energy losses in the transmission cable. Explain why the energy losses becomes greater when the length of the transmission cable is greater. Guys, this is your understanding of how a resistance works in a wire, right? When the length is greater, will the resistance be more or less? Yes. It will be more, right? And because it will be more, then obviously what's going to happen is there will be more heat generated in the wire, and thus there will be more energy lost to the surrounding, right? So literally you can just say that greater length of the wire creates a greater resistance in the wire. This causes heat to be generated and lost to the surrounding. Or anything along these lines, it doesn't matter. This is mine. Oh. Lost to the surrounding.
Shen, I noticed that you like to copy the word one word at a time. You know it'll be faster if you read the sentence and then write it down yourself. Don't copy word by word. You actually not learn anything.
Okay, then finally the last question here, they say discuss the advantage and disadvantage of using a transmission cable of greater cross-sectional area, guys. How does the cross-sectional area once again affect the resistance? Abiel, greater cross-sectional area, more or less resistance? More or less resistance, A or B? Greater cross-sectional area versus small cross-sectional area, which one has greater resistance? A has more resistance. You die now. Bloody hell, resistance is inversely proportional to the area. Remember or not? Greater length, greater resistance, greater area, less resistance. So what's the advantage of using a greater cross-sectional area? Number one, it will have less resistance in the wire, right? So this is your advantage. What about the disadvantage? In terms of an economical point of view, Rockwell, what do you think is the disadvantage of using a large cross-sectional area? Economical point of view, using more materials, what does that mean? It will cost more, right on. So this is your advantage and disadvantage, guys. You're supposed to say that using a large section, literally anything along these lines, you write your own advantage is literally less resistance in the wire. You write it down in your own sentence, guys, and the disadvantage is obviously more material, which will cost more. Anything along these lines, literally anything. And construct your own sentence. We're taking too long already. Okay, everybody. Okay, for those who are done, I want you to do the next question here. This one, the output AC generator of the power supply is 5,000 blah, blah, blah. Do this one right now. You have a maximum, of 7 minutes. Because I want to go to the next chapter. You have a maximum of 7 minutes, guys. 11:30, you have to give me an answer. Preferably your answer, not mine.
the pages. That哦，我还没有解释这个给你。可以，这个东西为了 I use this check，这个 really the one I just need to do. Okay. However, the something like say one high and the able to use very high rotation. Okay, since we really understand that how is the same. 今天 how is the same when I step up the voltage chart. 今天看那个 current 是 separating. Right? Why do you want the current to be less? Think of it in terms of transmission capacity. You know how current flows, right? And then just say the wire. Current will flow in this direction. And then you know that there's countless electrons flowing in this direction. And you carry it all, electron flow it all. Right? So you can, when you have near the rotation, it is very, very important that less current flowing. Exactly like that, we generated speed out of this. 这很远的区别嘛，对吧 ？Right? And because it's a very, very far away, right? Usually, these wires will actually, these electrons will actually generate a lot of heat in them. Should be once again more corrupting. So we don't want that. This is like no efficient here. But one member which one. So an hour is pain, right? An hour is pain. And increase in voltage. And increase in voltage really increases. Okay. When there is less current, you need to say that we less heat generated. Okay, which means that they are more efficient in terms of electricity transmission, right? And also means that there will be less power loss. Now, okay, because it's actually what we talk about. So, right, take it. Oh, sorry.
Can you look at humanity by destruction?
Yeah, right. That was one.
It's that there's some so
That is good. Chen, do you know where to refer to or not? You're supposed to refer to this one. 12 and Angel. You're supposed to refer to this piece of information here.
step down so you won't the circuit breaker.
Because most electrical devices are in of 230 volts. You know, like the TV, the laptop, the charger, your mobile, your phone, everything they receive 230. If you didn't step it down to 230, most problem. This is how you stream.
Most people can realize
No, only if you put
not big not we probably that oh.
Guys, you have 1 more minute to attempt everything now.
See some key questions.
Okay, everyone, you should have sufficient time to stare at the question already right now. All right. If not, guys, for those who do not know how to do the question, please pay attention right now. We're going to go through the answers. So first and foremost, what the question wants from you, it says that the output of an AC generator in a power station is 5,000 volts, and transformer increases the voltage to 115,000 volts before the electrical power is transmitted to a distance town. This is literally what I told you guys last week, right? Remember the transformer? You step up the transformer. Let's say, for example, this is TNP. You step up the voltage and then transmit the electricity. Then before it reaches our home here, they will step it down one more time, all right? Remember the diagram that I drew you guys last week? The beautifully drawn house that I was told was beautiful since kindergarten. Anyways, from here, they're asking you state and explain using a relevant equation. One advantage of transmitting electrical power at a high voltage. This here is literally with reference to that statement already. Yeah, which was in the note somewhere, right? Which was literally this one here, guys. Right. So from here, once again, you must understand that the relevant equation is obviously your power formula, right? What was the power formula again for electricity? Good, excellent. You're supposed to use P equals to VI. With reference to P equals to VI, when, pay attention first, guys, when we have the same amount of power, right, a higher voltage means to say less current, right? Less current means to say there's going to be less heat generated. Less heat generated means to say there's going to be less power reduced, which ultimately is going to increase your efficiency, right? So you're going to state something along those lines. So first and foremost, you're going to say P equals to VI, right? For the same amount of power. The higher voltage means lower current transmitted. Basically, lower current generation or much less heat. Reducing the power loss. Something along these lines. Optional, it's not really important, but I'm just writing that to let you guys know we're using the same power because we're assuming transformers have the same power in the primary coil and the secondary coil. Okay, everyone. Then after that, right, the next question, what do they want from you? They say that the transformer contains two coils, the primary coil and the secondary coil. State the other main component of the transformer and material from which it is made of. It is known as the what? Fusion, what is it known as? The other component of the transformer.
Oh, soft iron core.
Good. It is known as a soft iron core, guys. Soft iron core. Bam, easy one. Then which part should the AC generator be connected to? Anyone? Which part should the AC generator be connected to? Sorry? No, in the transformer.
I don't know.
Huh?
Generator.
What?
Huh?
Which part of the transformer should the AC power supply be connected to?
Output.
Output? You want me to beat you, Eugene? It's known as the primary coil, right? Yeah, which is the input. Why is it called output? Yeah, goddamn genius. Right. Then after that, this one is the calculation question mark. They say that there are 400 turns in the primary coil. This is essentially NP already, right? They want you to calculate the number of turns in the secondary coil, which is NS. So in order to find the number of turns in the secondary coil, you need to have the VP and also the VS, right? Voltage in the primary coil and voltage in the secondary coil. Because if you apply the formula, guys, VP over N, or actually maybe I'll swap it around. Vs over Vp would be equals to Ns over Np, right? Like I mentioned, there is no specific way to write this up because it is a ratio, guys. And then from there on, literally just substitute everything in. What's the secondary coil again? 11500. 115,000 over 5,000 is equals to the number of secondary coil which we're looking for over 400. Press this in your calculator and tell me how much should it be. I'm not quite learning this.
We were not following the
现在你是 year 10还是 year 11？
year 10.
你要转去我的 year 10 class 嘛？不然的话，I think maybe after this 你要转去那个 class like after this class when it ends。对啊。Okay, how much? 9,200. Do you all get 9,200? Yes. Right. And then final question, which is a concept question, guys. Transformers within the town reduces the voltage to 230 volts. Why is this important, guys? Why must we reduce everything to 230 volts before it is supplied to us at home? What's the reason? Anyone? Guys, the concept here is very simple. Most of your electrical devices, be it your TV, computer, aircon, refrigerator, blah, 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 right? Anything that is running on electricity, they are designed to take an input of 230 volts and then transform it again to the designated voltage. For example, this TV will take 230 volts and transform it to 10 to 15 volts. My computer will take 230 volts and transform it to 20 volts. My iPad will take 230 volts and transform it to 5 volts, guys. Each and every one of our electrical devices are designed to take in 230 volts. So most household appliances and then there's your answer. Eugene, you're quite a good artist. Do you get all my answers correct or not? Bloody hell.
Yeah.
Okay, continue, bro. Okay, guys, with that, I hope you have a little bit clarity of how the whole transformer question works, guys. We will go to a new chapter here today. I don't know even if we can finish this syllabus or not now. I don't know if we can finish this chapter or not today. I'll try to go through it real quick. By the way, everyone here takes chemistry, right? Anyone here does not take chemistry at all? Do you know how the atomic model works? Okay. If that's the case, right?
Everyone pay attention to this. I'm going to show you a very interesting YouTube video that explains how the gold foil experiment works, guys. Gold foil. This one. What's this guy? So it's on.
In 19.
Oh no. Wait. Maybe remove the video. Oh, what is okay, everyone, this was an explanation of how the atomic model came to be. Before this, you guys, it's in year 9, right? Remember, they thought that the atomic model was like a pudding shaped one, remember? You guys recall something like that? And then they thought that like the pudding, they will have protons and electrons all scattered around the pudding one, right? And then that was true until this guy discovered a new experiment to test out that theory, which is what we call the gold foil experiment. The gold foil experiment is very, very important, guys. Please watch this video. I'll explain bits by bits here. Pay attention, this is very important.
Performing experiments on radioactivity, Ernest Rutherford bombarded fast-moving alpha particles on a thin gold foil. He observed the reflection of the alpha particles with the help of a screen. Now, according to Thomson's atomic model, an atom consists of a positively charged sphere with electrons embedded in it.
This was the wrong model, guys. This was the pudding model that they thought. They thought that initially all the electrons and protons were all scattered in the atom one, right? Which is obviously wrong.
So, Rutherford expected that almost all the alpha particles will pass straight and only small deflections will be observed if there would be any. However, Rutherford got totally contrasting
You should bloody hell pay attention to this. Do you know this or not?
results. From his experiment, he made the following observations. First, most of the fast-moving alpha particles passed straight through the gold foil. Second, some alpha particles were deflected through the foil by small angles. And the third point, some alpha particles were deflected by large angles. In rare cases, an alpha particle got deflected by an angle of 180 degrees. Based on his observations, Rutherford derived the following conclusions from his gold foil.
Pay attention to this part here. This is literally the most important part.
Experiment. First, since most alpha particles pass through the gold foil without any deflection, most of the space inside an atom is empty. Second, very few particles suffered a deflection from their path. Now this means that positive charge occupies very little space inside an atom. Third and final point. As a small fraction of particles got deflected completely by 180 degrees, all positive charge and mass of gold atoms are present within a very small volume inside the atom.
Let me explain this. Guys, in your exam, when they come to the radiation physics chapter, they love to ask about the structure of the atoms, okay? Now this experiment, they'll ask something like this, guys. They'll say that, according to the gold foil experiment, how do you prove that most of the atom is made of empty spaces? Which you're supposed to say, you look at this yellow line here. You remember just now he said that most alpha particles that was bombarded through the gold foil is going straight through. This statement here, this yellow color line here is proof that most of the atoms is made of empty spaces. Then the question will continue something like this. Show what else, explain what else the gold foil experiment proved. right? Which you're supposed to pay attention to the red color line and the yellow and the blue color lines here, guys. This red color line and blue color line, right, proves two things. Number one, the nucleus is in the center of the atom. And number two, most of its mass and charge is located within the nucleus itself. This is the reason why, right, when I bombard these light alpha particles exactly to the middle, right, instead of this atom moving away, these alpha particles were reflected backwards here. This part here proves that the atoms contains most of its mass and charges within the nucleus itself, guys. This experiment only proves two things only. Like cut everything bullshit short, right? This only proves two things. Number one, most of the atoms is made of empty spaces. That's why alpha particles pass directly straight through. Number two, most of the mass and the charges are located within the nucleus itself, right? This is the reason why when some alpha particles hit exactly the middle, they will be reflected at a very large angle. When they kind of graze through a little bit of the nucleus, right, they will be deflected in a small angle here. Do you guys understand what I'm talking about? This is very, very, very important, guys. Okay. Anyone's got any questions for this part here? The second statement, most of the mass and the charges are located within the nucleus itself. This is the reason why when I bombard these light alpha particles and they hit the nucleus, right, they will rebound in a very large angle, or if they hit just a little bit like this blue color line here, they will be deflected in a small deflection. You get what I mean? Just proves two things only. Whenever you see the word gold foil experiment, you better have this image in your head, guys. It only proves two things: empty space, and most of the nucleus and the charges is within the nucleus itself. Okay? Okay, so if you look back here, yeah, and then atoms look something like this. For those who do not know, like an atom will basically look something like this. The nucleus is inside, and the electrons are orbiting outside one. That's why they call it the electron shells. For those who learn chemistry, for sure, you've seen this diagram before, right? So for you, now you need to know nucleus has protons and neutrons inside, and the electrons will usually orbit around the nucleus. That's why we call it an electron shell. Okay, so if you look at the first statements here, it's very straightforward. An atom is a complex arrangement of negatively charged electrons arranged in defined shells about a positively charged nucleus. The electrons are negative, the nucleus is positive because it has protons inside. Okay, right? This nucleus contains most of the atom's mass and composes of protons and neutrons. Like I said just now, most of the mass is within the nucleus and it will comprise of protons and neutrons, okay? Atoms may form positive ions by losing electrons or form negative ions by gaining electrons. In chemistry, right, you know, like how can one thing become positive or negative? It's not because they have extra protons then they become positive. No, that is not the case. In order for anything to become positive, they must lose its negative component, which is its electron. Okay, and in order for anything to become negative, they must gain extra negative components, which yet again is the electrons, because electrons are the only things that are free moving. You know, right? Like from the conduction chapter, we learned that there are only free moving electrons. There's no free moving protons. No such thing. Okay. Then after that, this part here was going to be the gold foil experiment, right? The gold foil experiment, cut the bullshit short, basically just proves two things only. Number one, most of the atoms is made of empty spaces. That's why most of the alpha particles will pass directly straight through. Number two, most of its mass and charge is located within the nucleus itself. That is why if I hit it hole in the nucleus, then it will turn back. It will have a huge deflection. If I just graze through it a little bit, it will have some form of deflection here, right? So if you look at the statements, which is literally everything I said in a more structured manner, Rutherford's gold foil experiment states that atom has a nucleus and is positively charged, contains most of the mass of an atom, and has space in between each and every one of the atom, surrounded by a cloud of negatively charged electrons. Okay, which is just an enhanced version of what we taught here, right? Just that electrons are here right now. Okay, it's the same thing, it's just a different representation now, right? How do we prove that? How do we prove that it's all empty? Most of the atom is empty spaces is because most alpha particles pass the atoms in a straight direction. Most atoms contain empty spaces. This one here proves that it has empty spaces in between them, right? Some alpha particles are deflected. This means to say that the nucleus is positively charged, and also most of the mass is contained within the nucleus itself. Very few alpha particles deflect more than 90 degrees because most of the mass of the atom is concentrated in the nucleus. Okay, if you ever see the word Rutherford's Goldford experiment, you better have this picture in your diagram in your head. This diagram in your head. Yeah, right. This only proves two things that I keep saying over and over again: empty spaces, mass, and charge in the nucleus itself. Okay, so usually the atomic representation in terms of your chemistry, right? This will be the element symbol. It could be anything like helium, what's it called? Helium, hydrogen, magnesium, all those kind of things, right? This is what we call the element symbol here. This part here, the number on top, will usually be your nucleon number. A nucleon number is basically just the combination of what and what again? Proton and neutron. Okay, proton number plus neutron number is known as the nucleon number, guys. And obviously this part here is just the proton number. Okay, so in other words, if I want to get the neutron number, I can just put this number, this number minus this number. For example, let's say for example today I have some random element. I'm not very good with chemistry, so I don't actually remember the element symbols. But let's say today I have like carbon, okay, carbon 16(7). I don't think this is the correct number, but it doesn't matter. This is not chemistry, right? So the question will be something like this. They'll say that identify the composition of the nucleus. If they ask you the composition of the nucleus, right, you're supposed to say that the nucleus has 7 protons, right, and 7 protons and 9 neutrons. That's the composition of the nucleus, right? Because it's 16 minus 7, then you get the 9 neutrons here. Okay, so if you look at the statements here, nucleus are made of protons which are positively charged and neutrons which are neutrally charged. Okay, the sum of proton and neutron number are known as the nucleon number here. Very important. Hey, can you copy this symbol down real quick? Just label everything that I've mentioned so far. Or sometimes in your exam, they will also give you the atomic mass number, which is also known as the nucleon, and the atomic number, which is also known as the proton. Or they have some other name for it, I can't remember. What's the other name for proton number again? Atomic number, is it? Yeah, most likely. But chemistry has always been the bane of my life. So I actually do not know anything much about chemistry besides those that are in the physics chapter. In chemistry also, right? Okay, once you're done copying, flip to the next page. Okay, the next thing you're basically going to learn are things known as isotopes, guys. Isotopes, right, which you have learned in chemistry also, except for you, right, are basically things with the same proton number but different neutron number. Okay, or you could say like elements with the same proton number or different nucleon number, which is essentially the same thing. Okay, for example, today, if you see this here is one example of isotopes, you will see that they all have the same proton number, They have one proton, one proton, one proton, but they'll all have different nucleon number or neutron number. For example, this one has no neutrons, this one has 1 neutrons, and this one has 2 neutrons. In your exam, right, they love to ask you to define what an isotope is. And the answer is dead straightforward, guys. They'll say that define what an isotope is. You're going to say isotopes are atoms of the same element that contains different number of neutrons but same number of protons. But this one here, you can interchange. You could even say nucleon number is acceptable as well, guys. It's acceptable. If it is 2 marks, you just write this. Is good enough already. But if let's say it is 3 marks, guys, which sometimes come up in your exam, you must mention that they still have the same chemical properties. If it's 2 marks, they ask you what an isotope is, just say the standard answer in chemistry. Same proton number, different neutron number. That's fine already. If you see that define what an isotope is and they give you 3 marks, you say same proton number, different neutron number, but same chemical properties or same chemical behavior or whatever along those lines. Okay, everyone? Understand? This one always comes out in your exam. You need to know how to define it. Copy this down real quick. Copy this down real quick. Eugene, you bloody fool, have you copied down everything? Eugene, how would you say you did for your paper 4 in school a few days ago for physics?
Well, I just put the
Doing
that bother me is the calculation. I think there is easier.
So you cannot do the calculation, but you can do the theory.
I mean, by theory, then it's the calculation.
How about you? Exactly opposite. Calculation can do, theory cannot. Okay, duly noted. This is an electron, by the way. Oh, by the way, electron number and proton number will always be the same thing. Electron number and proton number will be the same thing. If not, it will become an ion. For example, if I have 1 electron more than a proton, it will become a negative ion. Or alternatively, if I have like one proton more than the electron, then it will become a positive ion. You understand what I'm talking about? Positive and negative ion. Okay, don't take your sweet time to draw it. I want to go to the last part already. Just sketch it is good enough. You'll never be asked to draw this, by the way. It's just for your understanding. Okay, done. Okay, then last part I want to talk about today is basically the difference between nuclear fusion and nuclear fission, guys. Who here can give me an example of what a nuclear fusion is? And who here can give me an example of what a nuclear fission is? Where does nuclear fusion occur, boys and girls? I think I've kind of mentioned this before in class. Where does nuclear fusion occur and where does nuclear fission occur, guys? Starting off with fusion first. Where do you think it can occur? Sorry? Not exactly my answer that I'm looking for. Where does nuclear fusion occur that you know of? Somewhere very, very far away. Oh. Good. Nuclear fusion occurs only at the sun. Guys,
Nuclear fusion is literally like the name suggests, two hydrogen atoms combining together, fusing together to form one larger atom, right? Nuclear fusion when they form together, right, it actually releases off massive amounts of energy, and because of that, the sun can continuously burn itself for billions and billions and billions and billions of years. By the time the sun runs out, we are long dead already. Okay, nuclear fusion can only occur in two specific conditions: very, very high pressure and very, very high temperature, which is exactly what's happening on the sun right now. We currently, right now, with the technology of Earth, we are actually trying to mimic nuclear fusion to occur, because nuclear fusion releases massive amounts of energy, which are clean energy. If we somehow manage to harness nuclear fusion, right, electricity is going to become dirt cheap already because of the massive amounts of energy it releases. But because of our limited technology right now, we can only use nuclear fission, which only happens in the power plants, guys. You know, like nuclear power stations, right? Nuclear power stations are actually harnessing the power of nuclear fission. Nuclear fission is the exact opposite. If fusion was combination of two atoms into one larger atom, right? Fission is the separation of one larger atom into two smaller atoms, right? Nuclear fission only occurs when there's either uranium or plutonium, which is exactly what's happening in the nuclear power plants, especially in Japan. And then when nuclear power plants fail, right, the radiation toxicity is damn high, and usually they'll have to abandon the whole city, if not the whole area, just to clear out the background radiation. Okay, like for example, you know Hiroshima and Nagasaki? Everyone knows. You don't know about Hiroshima and Nagasaki? It's the most historical thing that happened in Japan. You know what happened, right? The World War, and then the Americans bombed the Japanese when they wouldn't retreat their troops, and then they let down two nuclear bombs, right? Those nuclear bombs was this one. The nuclear bomb, when it landed, right, the amount of energy bursted into the air, and then it was like a large mushroom cloud that formed. Go look up Hiroshima and Nagasaki on YouTube. It's it kills instantaneously. You know, like if you ever watch the cartoons where they are burned by radiation, their body kind of melts away, right? This is literally that scenario. If today you're exposed to large amounts of radiation, right, your body is actually going to melt away because of the instability of your DNA and your genes, everything really. I've heard a statement from one of my previous teachers before. When the bomb dropped in Hiroshima and Nagasaki, the light was so bright that all the soldiers were instructed to close their eyes and cover with their elbow. And even when they were covering like this, right, when the light struck, it was like they saw, it was like an X-ray vision shining onto them. They could see the bones in their own flesh and bones, you know. So the nuclear bomb is no joke, man. And meanwhile, we have Kim Jong-un every day. It's like, yeah, he plays it like a joke, but yeah. So yeah, this is essentially the main difference, guys. You need to know that nuclear fusion can only occur in the sun, but Earth is actually trying their new experiments to harness the nuclear fusion. But currently, right now, due to the limitation of our technology, we only can do nuclear fission, which is actually occurring in the power plants. Okay, remember, very important. Okay, if you look at the statements here, it is essentially everything that you should know. The sun's energy is produced through the process of nuclear fusion in its core. Nuclear fusion involves the collision and bonding of hydrogen nuclei to form helium nuclei, right, releasing nuclear energy in the process, which is, in other words, the energy that continuously burns the sun. Okay, nuclear fusion, however, a uranium-238 nucleus is struck by a neutron. Usually this neutron will smash this thing, and then it will split, and then it will release its own neutrons, and it will smash other things, and then it will once again split and split and split and split and split and split, breaking it into two smaller daughter nuclei, or N2 to 3 neutrons, guys. If you want, this is a graphical representation of how nuclear fusion and nuclear fission occurs, guys. Yeah, please copy this down real quick. You have 2 minutes to copy everything down real quick.
为什么这三个是单独？
什么？
是蓝色的。
这3个是 from 这边的，所以这个东西，这个 neutron like smash into this thing, then 它 split into 2嘛，然后 at the same time it releases 3 more neutrons to split into 2, so it's like a chain reaction 啊，它一直猛拔，一直 split， 一直猛拔，一直 split， 一直猛拔，一直 split 的，明白吗？These guys. Save when you guys are going there. Oh, are you staying for MX? Are you staying for MX? Okay, so last part here. Basically, cut the bullshit short. Fission is a process in which large nuclei are split into 2 smaller nuclei, releasing energy in the process. Fusion is the opposite of that, involving taking 2 smaller nuclei and bringing them together to form a bigger nucleus. Okay, I can't remember what this was already. I'm sorry, what?
Let's include and bring.
Sorry? Okay, good question. Actually, nuclear fusion, right, it releases much more energy than nuclear fission. Fusion releases much more energy than fission. But because of our limitation in technology right now, we cannot harness nuclear fusion yet. But they're doing a lot of things right now. You know, like the nuclear collider. You guys ever read any science-related articles?
Yesterday I watched a video saying American 他们在搞这个。
对，他们已经在搞这个了。They are already building the nuclear colliders.
to harness nuclear fusion. You know what's actually happening right now? Actually, we can do nuclear fusion at right here, but we won't generate any electricity. So let's say for nuclear fusion to occur, we need two smaller nuclei to bombard together, right? And in order for them to form together, we need to put in a lot of energy, you know. Let's say right now, right? In order for these two to form, we need to increase the pressure and temperature, right? Let's just say we need to input 1000 joules. But when this occurs, right, the amount of energy it releases is only going to be like 500 joules only. So this is an energy deficit. We won't be able to generate electricity. We can do it right now we can, but it's against the point because we're putting in more energy than the output. Alternatively, right, for fission what's happening right now is, right, when we want one atom to split into two, right, what we do is we just input some energy to it. Let's say we input like 500 joules of energy. And when this thing splits into two, right, the output energy is 1000 joules. This is an energy surplus, right? That's why right now we are only harnessing fission. We can do fusion also, but you put in more energy than the output, so you're not going to generate any electricity at all, which is in other words useless, right? So, but America is already doing a lot of things. They have this, like, I think a football field laboratory that is going to make like a nuclear collider. They're basically like shooting two neutrons or atoms or nucleus, and then they're accelerating it at the speed of light and bang them together. It's quite an interesting topic. You can definitely go Google a little bit information about it, then you'll know what's going on. Okay. All right, guys. Do we have enough time to do one question? Yeah, can you guys do this question real quick? In 3 minutes. In 3 minutes, guys, please answer everything.
Oh. Right.
Be right back. Please attempt this in 3 minutes, guys. Then I will go to the next. Oh, I read the You're supposed to complete the call. Okay, due to the time constraint, I must discuss the answers right now, boys and girls, and then I gotta go to the next task already. Okay, if you look at the first question here, very straightforward. Figure 1.1, 11.1 shows 5 nuclei and of atoms in one layer of gold foil. Oh my god, gold foil. It must be something related to Rutherford, right? Also shown in the path of 3 alpha particles directed. On figure 11.1, complete the path of the 3 alpha particles. It kind of hits the nucleus a little bit, right? So you deflect it a little bit. Because alpha particles are positive and the nucleus are positive, so it goes through some form of repulsion. This one will go directly straight, and this one will obviously be deflected in a very large angle, which is essentially what you're supposed to do, right? It doesn't matter. Okay, then after that, state the results of the experiment that shows that the atoms consist of very tiny charged cores containing almost all the mass of the atoms. Which part of it shows that it has all the mass of the atoms? A, B, or C? A, B, or C, or most of the mass. C lah, right? The alpha particles being deflected, being rebounded in a rectangle. State the sign of the charge of this core here. What kind of sign should it be? What kind of sign should it be? Yes, Jesus Christ. Positive charge. Right, for sure, the nucleus must be positive charge. Right, and then state what occupies between the space in between these charges here. What's that? What occupies these things, Abigail? The mass your head are empty spaces, empty spaces in between the charge core. Right or not? Then proton and neutron, how much and how much? How much do you write? You
Wait.
Good.
No, I got the answer. Oh, okay. I was about to say 2-2.
Sorry, Leo. I guess I asked time. Okay, guys, these are your answers. Please make sure you know how to do all these things. You can even attempt some of the questions at the bottom, guys. But as I've mentioned in a few classes right now, what I'm trying to do is I'm trying to rush through the whole syllabus so that we have enough time to do some past year papers by either mid-March or early March. Okay, everyone, that's going to be it for today, guys. I'll see you all next week.
Bye.
Bye-bye.